right, guys, we are at a little over the halfway point of this chapter. We're on day 4, and we're going to be introducing something called function operations. Now, you guys have heard of the order of operations. When we talk about operations, we of course mean adding, subtracting, multiplying, or dividing. And you're going to notice here, that's exactly what we have: adding, subtracting, multiplying, and dividing. Ooh, wait a minute, functions, as in plural. And then tomorrow, so this is going to be part 1 of day 4. Tomorrow, on part 2, we're going to be discussing the idea of composing two functions together, putting one function inside of another. But we won't get that complicated yet today. So now, we've been talking a lot about how to work with one function. Let's talk about how we can combine two functions. So check it out. If you want to add two functions together, we'll call f plus g of x. We'll call this the first function, f of x. And g of x will be our second function. We can add those two together. Sometimes you'll see it written like this or like this. Same thing. Subtraction, similar idea, f minus g of x. That really just means f of x minus g of x. F times g of x is really f of x times g of x. And then finally, division. This one's going to be usually a little bit easier. We just stack the two functions on top of each other. The first one, f of x, being divided by g of x. As long as, and we talked about this yesterday, denominator can't be 0. That's huge. The bottom cannot be 0, and that's actually going to come into play when we talk about our problems down here, because we're going to have to find the domain for a division we set up. And we talked about yesterday how when it comes to the domain, we'll talk about that in a little bit, what that means. But first, check it out. We're doing 3 things. First, f plus g of x, we're going to add the first function with the second function. Then we're doing f minus g of x. We're going to subtract the first function from the second function. And finally, we're going to divide these functions. So let's start with the first one, guys. We got part A. That'll be it'll be f of x plus g of x. So what does that look like? Well, that's going to be 4x plus 6, which is f of x, plus g of x, 2x minus 10. And you're going to notice, always put these in parentheses, guys. Number 1, it helps you tell where the first function begins and where the second one, or where the first one ends and where the second one begins. But also, when we do subtraction, you're going to have to distribute that negative to both. So just keep that in mind. Let's see what happens. So we add these two functions together. So we've got 4x plus 2x. Do you see how we don't have like an equation? This is all on one side, so we can just smash those together. 4x plus 2x, going to be 6x, and then 6 plus negative 10. Well, that's like 6 minus 10. That'd be negative 4. And guys, that is our new function. That's the new creation we get when we add those two functions together. How about B? F of x minus g of x. So once again, we have parentheses 4x plus 6 minus, instead of plus, 2x minus 10. This one's a little bit tricky, guys. A little bit tricky here. So 4x minus 2x. Another way to do this is you could just go ahead and distribute that negative to both of them. So that becomes a negative, that becomes a positive. So 4x minus 2x is 2x. 6 minus negative 10. Ooh, that really becomes a plus 10. So 6 plus 10 That's 16. There's our new function when we subtract these two together. So we get two different answers depending on how we combine our functions. The last one, C. F over g of x, so we've got f of x over g of x. So that will be 4x plus 6 over g of x, 2x minus 10. And that would be your answer. But additionally, check this out. Determine the domain for part C. This is part C. Remember, this is from day 3. We talked about this on day 3, part 2. This was yesterday's lesson, day 3, part 2 here. If you have a fraction, your domain are all of the x values that give an output. In other words, your domain is the input. So if x could potentially be something that gives us no solution, it is not in the domain. So check it out. We know we can't divide by 0. We've got a fraction here. If you see a fraction, we need to pull out the denominator here. We know 2x minus 10 absolutely cannot equal 0. If it does, you're dividing the whole thing by 0. So let's solve this equation here. Let's find out what x cannot be so we know what to exclude. So add 10, divide by 2, and it turns out x cannot be 5. Well, why can x not be 5 is probably the question you're asking. Well, try plugging that back in. What would happen if x was 5? 2 times 5 would be 10. 10 minus 10 would be 0. Can't have 0 in the denominator. So our domain is going to be every number but 5. Negative infinity to 5 parenthesis, so we don't include it. Unioned with, and I don't have enough room, so I'm going to drop down here. Right after 5 to positive infinity. We use the union to jump over where we stopped before 5 to where we start again. All right? I want you guys to try number 2 for me. Try number 2 here. Let's see what you guys can do. We're doing the same 3 things. A, see how I have them labeled? Probably be a good idea to label them like that yourself. A, B, and C. And go ahead, guys, and see what you can do on number 2. All right, let's see how you guys did. So, here is part A. We add these two functions together. 5x plus 4x gives you 9x. Negative 16 plus 7 gives you negative 9. 5x minus 4x gives you 1x. Or you could have just put x there. You don't have to put the 1. Then negative 16 minus 7 gives you a bigger negative. That'd be negative 23. And then finally, we divide f over g, 5x minus 16 divided by 4x plus 7. And on top of that, we want to find the domain for part C. So we want to find what can be an input for x and what can't be. So we look at the denominator because we know you can get 0 up top. If the top is 0, that's okay. If the bottom is 0, we have no solution. That's not good. So we know the bottom cannot equal 0. We solve it, subtract 7, divide by 4, and you end up that x cannot be negative 7 over 4. So our domain then is going to be everything but negative 7 over 4. So everything from negative infinity to negative 7, 4 parenthesis, because we can't include it. We use parenthesis here because you can't reach negative infinity. We use it here because you can't actually reach negative 7 over 4. Unioned with, parenthesis, once again, negative 7 over 4. So we stop right before, then jump over it, and then we head to infinity. So that would be our domain. Yep. There's our division. All right, guys, last thing for today. Let's flip over to page number 16. So what it's going to do is it's going to want us to refer to example 1 and example 2. While you're reading the instructions, I'm going to go ahead and write down what those examples are from the previous page. 4x plus 6, 2x minus 10. All right, there's our first one. And then the second one is 5x minus 16, 4x plus 7. Okay, so there are two functions here. So what are we doing? Well, we're going to review how to do some function substitution and then how to multiply their values afterwards. So the key here is we're going to substitute numbers into each of these and then take those two answers and multiply them together after. So using our two functions from the previous page, we want to find f of 2 and g of 2, and then afterwards find their answers, f of 2, and multiply it with what we got for g of 2. So let's start here. F of 2 and g of 2. Well, that means instead of x's, f of x, g of x, instead of that, we're going to be plugging in 2 for x. 2 for x. So we'll have f of 2, that will be f of 2 equals 4 times not x, but 2 plus 6. And for g of 2, that'll be 2 times not x, but 2. I bet. Minus, it's a minus, a big old minus 10. So let me work these out. 4 times 2 is 8. 8 plus 6 will be 14. G of 2, 2 times 2 is 4. 4 minus 10 will be negative 6. And now that we know what G of 2 is and we know what F of 2 is, we're going to multiply their values afterwards. So now we say, okay, F times G, when you've plugged in 2, is going to be 14 times negative 6. So we got one answer there, we got one answer there, and now using our calculator, 14 times negative 6, negative 84. And so that would be what we get when we take both those answers and multiply them together. All right, last problem of the day I'm going to let you guys try. Number 2. Here's our function for f, 5x minus 16. Here's our function for g, 4x plus 7. So go ahead, guys. Try using these to find f of negative 7, g of negative 7, and then multiply their products together at the end. Go ahead. All right, let's see here, guys. So to find f of negative 7, we plug negative 7 in for our function. So that'd be negative 35 minus 16, or you just type it all in. Be negative 51. Then 4 times negative 7, that'll be negative 28 plus 7, negative 21. And now we're going to take both these answers and multiply them together. We're going to get a ginormous number here. So negative 51 times negative 21 will be, oh, calculator died, 1,071. My goodness. So that would be both answers multiplied together. And so guys, make sure we are working on our Delta math. Be ready, our exam will be coming up. Make sure we're staying caught up. If you have any questions, please let me know. Otherwise, I'll be seeing you guys tomorrow to finish up day 4. So go Jumpers.